Here we'll learn yet another method of separation, and that is crystallization. So here is some impure substance. It is a mixture of two. So this impure substance is dissolved in water, in a minimum amount of water. In this road solvent, it usually in water, and then it could be filtered. This could be filtered to remove any impurities. The solution in the step 2 is then evaporated. As it is evaporated, the extra solvent evaporates and moves out of the solution, and hence we get a saturated solution. It is important to get a saturated solution for crystallization. Now once a saturated solution is obtained, it is then allowed to cool down here in this china dish for about at least 24 hours. And after 24 hours, you will find there are crystals here of the substance, while the impurities remain in the water up here. It is then filtered out and crystals are dried and obtained on the filter paper. So this is a thing from your textbook. So crystallization is a process that separates a pure solid in the form of its crystals from a solution. Now crystallization is better than evaporation because point 1 is some solids decompose, or like sugar may get charred on heating to dryness. Like if I have here a solution of water and sugar, here I have water and sugar, and I want to separate it out, I have an option of heating it. And when I heat it, what happens is the water begins to evaporate out, leaving behind the sugar. But what if I continue heating the water and I don't stop heating the sugar? This sugar is going to get charred, it's going to get burnt. There is a possibility the sugar gets charred, but if I were to use crystallization for this method, there is no heating, so there is no possibility of the sugar to get charred. I would get all crystals of sugar settled here at the bottom. Crystals of sugar. So this and the impurities would remain out here in this liquid, and it could be filtered out. The same thing goes for salt water. If from salt water, if I want to obtain salt, and if I have to evaporate it, remember in the salt water, in the sea water, there is not only salt, there could be also other impurities which I marked as green, and if when I evaporate, the water will move out, leaving behind not only salt, it would leave behind salt plus the impurities. So I will not get pure salt. But if I use the method of crystallization, remember in crystallization there is no heating, so I don't heat, I just allow it to crystallize. So I'll get here water with all these crystals of salt down, while the impurities will remain up in the water, and they can then be filtered away. So here I get pure salt. In evaporation I don't get pure, I get a mixture of salt and the impurities. So crystallization is preferred to evaporation. Here are some applications of crystallization: purification of salt that we get from seawater, and the separation of crystals of alum from impure samples. Summarize this, what we did in crystallization. We first had the impure substance here mixed with water to form what is important is saturated solution, and this saturated solution is then allowed to cool, and when it is cooled you get crystals of the substance. The impurities remain behind in the water.